All right, L'Hopital's rule, example 3, part A. And again, we're applying a limit to a fraction. So there is the potential that we would prescribe L'Hopital. But again, we must check to see if that limit is indeterminate by substituting 0 or whatever we're approaching in for x. So 0 squared is 0. And in the numerator, you got to check them both, right? So the numerator, e to the 0 power, grab a calculator if you have to, but you learned a long time ago that anything to the 0 power is 1, so that term would be 1, minus, put 0 in for x, 0 minus 1, the numerator is indeed 0 as well. Yeah, yep, it's indeterminate. We do indeed prescribe L'Hopital. We apply L'Hopital's rule, which would mean that we take the derivatives of the top and the bottom individually. It's not the quotient rule. Derivative of numerator, derivative of denominator. X squared has a derivative of 2x. What's the derivative of e to the x? Anybody remember that one? Oh yeah, it's e to the x. What's the derivative of negative x? Negative 1. And what's the derivative of 1? 0. 0. All right, as we discussed earlier, before we check again, let's see if we can cancel anything. I don't see anything going on there. You can't cancel an x or anything like that. Okay, let's check it again. So we'll put 0 in for x here. 2 times 0 is still 0. We put 0 in for x up here. Well, e to the 0, what's e to the 0 power? What's anything to the 0 power? 1. That would be 1 minus 1. Looks like the numerator is still 0. Is it still indeterminate? Yep, sure is. Is it appropriate to prescribe L'Hopital again? Yes, I believe so. So, again, we take the derivatives of the numerator and denominator individually. The derivative of 2x is 2. The derivative of e to the x is e to the x. And the 1 derivative is 0. By the way, I think we're done here because the denominator is 2, isn't it? There's no variable left down there. Doesn't matter what x approaches, 2 is going to stay 2. Plug 0 in for x upstairs. And e to the 0 power. What's e to the 0 power? What's anything to the 0 power? 1! That's right. 1/2. Boom. Cool. All right. I think we got a couple more left to enjoy on this particular slide.